Okay, good evening all. In the last class, we have discussed about the basics of electronics circuits analysis, okay, electronic circuit analysis. So, in which we have discussed about the various circuits and the devices, how the electronics is developed from its minute particle electronics level to electron level to its electronics. We have already discussed about the rectifiers, oscillators, amplifiers, and so many analog circuits we have discussed in the last class. So, according to our subject, the analysis of the electronic circuit is the matter. So, analysis of electronic circuit is individually complicated matter. So, in order to avoid that complication, we need to invent some parameters. So, what is the analysis of an amplifier? Suppose amplifier, we are giving the input and taking the output. We are already discussed in the last class. The amplified version available at the output. But in the analysis, we have to derive the expressions for input impedance and output admittance. How much the voltage gained by the circuit? Voltage gain including source. We are applying the source. Voltage gain including the source. And the current gain of the circuit, amplifier circuit. These are the important parameters you have to derive from an electronic circuit amplifier. So, in the diagram, amplification diagram, there is a biasing circuit, there is an input circuit, there is an output circuit. Analysis to derive these parameters in the circuit level is complex. So, in order to make it easy to analyze an amplifier circuit, we are introducing one concept, that is hybrid parameters. Today, I will discuss about these hybrid parameters, simply called as H parameters. These are mostly used in amplifier analysis. They are specially used for amplifier analysis. These H parameters are H parameters. Here H is hybrid parameters. What are the hybrid parameters? Suppose we are taking an amplifier circuit. By using a network analysis, we will make that amplifier circuit, all these parameters are in the network form that is called as two-port network. Two-port network. The hardware circuit of an amplifier is converted into two-port network first. In this, two ports are available. According to the name, there are two ports available. The ports are named as input port and output port. Input port, the first port is input port. The second one is named as automatically the output port. Input port and output port. Input port contains only the voltage parameter, so it is called as voltage port. So it is called as voltage port. The output port is completely current source, so it is called as current port. Okay, here the names are important because the input port, what available? Only output, only voltage available. Only voltage available in the input port. Only current source available in the output port. So, these ports are designed as a circuit that is called as two-port network. In the network formation, the diagram is this is the first port. it has the voltage source. The voltage source is identified like this, a sine wave. This is input port, input. This is named as input voltage VI, the source voltage. Completely a voltage port. So the source is input voltage. Next port, second port. This is current source, the flow of current direction. In a current network, the resistance must be connected in shunt. In the voltage source, voltage port, we are connected the resistance in series. We know about that. So this is ground. This is ground. So here for the second port, it is a resistance is connected in shunt. This is the current source. In input source, input voltage source, and the resistance. Here we are naming this circuit, two-port network, as input voltage VI, input resistance RI. Simply, first of all, input resistance RI. So voltage port is there, resistance is there, is a passing of current, that is called as input current II. This input current flowing is II. Here this RI is observe the diagram once. This is input port. This is output port with the resistance. Voltage, current. Input voltage VI. So this is current II. This is resistance RI. In the previous case, I written that RI. Now I am written this HI. Here the voltage source is defined like HRE VCE. I will explain why these are named like this. I will explain. In this port, this is the current, output current flow, I0. Okay. I0, IL, we will call IL, I0 differently because the current magnitude is same, directions are opposite. So we can write the analysis is I0 equal to minus IL. Okay, so this is IL. IL is opposite to I0 in direction, but the magnitude is same. In the current source, this is named as HOE. Here also it is denoted as HIE. Why? Because we are writing like this. I will explain now. This is the current source in the port, current port. This is called as, in H parameter model, the current source is called as HFE. HFE IB. Here IB is the base current. What is HFE? What is HRE? What is HIE? What is HOE? We will discuss in this class clearly about these parameters. These are the 4 types of H parameters used in amplifier analysis. By using the H parameters, why we are going to H parameters means these are constant parameters. The constant at high temperatures. If the temperature is increased, the circuit parameters are not changed. This is the major advantage of H parameters. So convenient to understand. Constant. These are the advantages. So we are preferring the analysis of amplifier. Okay. So here the 4 types of parameters, H parameters. I named in the circuit HIE. E because common emitter configuration. Common emitter configuration. Common emitter. Emitter is grounded. It is common to the 2 ports. Emitter. So here base, collector. So as per our circuit. Okay. So base, collector, emitter is grounded. So HIE means input resistance in common emitter configuration amplifier. Suppose it is common collector, we can write HIC. Suppose it is common base, we can write HIB. This is the notation of the type of amplifier. Okay. So here HIE, HRE, HFE, HOE. According to the input port is the voltage, output port is the current, we can write the 2 equations. Those are, first one is for input port 1 to determine the voltage drops. Voltage drops in the port. Okay. So VI, H11, II means input current passed through the resistance here. H11 II plus H12 V0. H11 II plus H12 V0. I can write the output port is the current port, output current I0 equal to H21 II plus H22 V0. Why I am notifying this 11, 12, 21, 22? There is a big meaning. The parameter H parameter H11 is the parameter in the input side only. It's not transfer. Only input side parameter. Suppose comparing with H12, H12 is transferring from first port to second port. That is called as H12. But here H11 is itself in the port, input port. Okay, that's why H11 is identified, H12 is identified like that. H21 means this is the parameter, it is transferred from second port to first port. H21, here the transfer, this meaning is transfer from one port to other port. It should be notified. Okay. So H21 second port to first port transfer. H22 the individual port parameter. 22 means the second port parameter. There is no transfer. Okay. So what are these parameters? H11. How we can identify H11 is resistance, H12 is gain, H21 is current gain, H22 is admittance, like that I am telling, but we are not understanding H11 means there is a possibility to ask a question. So we can identify using these ports. H11, the first port to first parameter, HIE. HIE is called the first port parameter, H11. HIE, that is the parameter resistance, input resistance. This is the first hybrid parameter, input resistance Ri. Okay, so this is identified as input resistance Ri. Why we are writing in this equation? This equation is a voltage equation. This drop must be voltage. This drop must be voltage. Suppose H11 is the input resistance. We know that input resistance equal to input voltage divided by input current according to Ohm's law. Ri equal to Vi by Ii. So this is placed in H11 because H11 is HIE. Ri is placed in H11. Ii must be cancelled here. Okay, suppose here we are writing this clearly, H11 Ii. H11 means Vi by Ii. Vi by Ii cancel just the remaining. We are observing this. H11 is voltage drop. Vi equal to voltage drop plus voltage drop, input voltage drop. So we can easily identify these parameters using these two equations. We must form the two equations because good understanding about these parameters. Without these two equations, we cannot understand clearly about these parameters. H11, H12, H21, H22. So now we can go to the H12 parameter. H12 parameter. This is called as, this is input resistance. Okay, notify this. Input resistance. HRE, I named this as reverse voltage gain. Reverse voltage gain. What is gain? In the amplifier circuit, we are concentrate about gain only. Gain is the most important parameter of the amplification. Okay, so what is gain? How much the amplifier circuit gained? It is calculated by using the formula output voltage, ratio of output voltage to input voltage. This is the gain. Okay, this is reverse voltage gain. So the ratio is reversed. Vi by V0. Actual gain is output voltage to input voltage ratio. But reverse gain is reverse voltage gain, input voltage to output voltage. Okay, input voltage, output voltage. So this parameter H1 to V0. H1 to V0. H12 means reverse voltage gain. That means input voltage by output voltage into output voltage. Cancel. Remains Vi. Vi equal to Vi plus Vi, the branches. Voltage drops. Okay. So that's why this is named as H12. The gain transfer from input port to output port. Reverse voltage gain. Port 1 voltage to port 2 voltage, H12. You are observing this clarity. Okay. Next parameter H21 II. H21 I named as HFE. This is forward current gain. Forward current gain. Forward current gain, according to our definition for the previous topic, voltage gain, the same definition applied for this current gain. Output current to input current ratio. Forward, okay, I naught by II. So here we can check H21 II. H21 means forward current gain. Forward current gain means I naught by II into II. So II cancel. Here remains I naught equal to I naught. So this is the transfer from output port to input port. So it is named as H21. Transfer from second port to first port. Okay. Next, one more parameter, that is, okay, the last one more important parameter is HOE. This is called as output admittance. Output admittance. Here the parameter admittance is the reciprocal of resistance. The reverse resistance is called as admittance. In any network, we should maintain the input impedance, that is called as resistance. Output admittance, here admittance means the reverse resistance. Okay, according to the reverse resistance, admittance, reverse resistance 1 by R naught, output resistance. Okay, so here the parameter H22 in itself, resistances are not transferred from one port to another port. These are individual parameters. So H11 is the resistance at input, H22 is the resistance at output, but it is reciprocal. So it is called as admittance. Okay, admittance, how we can identify H22 is the admittance? H22 is the admittance. Reverse resistance means resistance R equal to V by I according to Ohm's law. Reverse resistance 1 by R equal to I by V. So admittance is I naught by V naught. At output H22 is I naught by V naught, reverse resistance into V naught. Cancel, cancel, I naught. Here the four parameters are discussed. The four parameters are discussed according to the transfer. H11 itself resistance at the input, H22 itself at the output, reverse resistance named as output admittance. Next, these are 1, 2 means H12 means reverse voltage gain. The reverse voltage gain, this is forward current gain H21. So remember these words, these parameters very well. Next we are going to the analysis of the amplifier. There must be complete derivation and following these rules. The simple derivations are there in order to analyze a circuit by applying the source and observe the load at the output using this circuit. This is the basic circuit. We are applying source here, we are observed output at the load. Then we are adding the source resistances, load resistances, and analyze the circuit using these parameters. Okay, so let us consider this circuit and terminology and use this notation and identify immediately what is the parameter. Okay, this is the main aim of this class. So next class we can analyze the circuit.